Alright, we're going to pick up where we left off, and what I want you to do is actually pause the video and try to do this proof on your own. Okay, see what you can come up with, and then maybe compare with what I write down here. Alright, so I'll let you pause it. I'll assume you just paused it and tried it, and now I'm going to do it out and see how yours compares with mine. So I think the natural side to start with is the left. It's a little more complicated, so I start with that. And what is there to do? I mean, I know I need to end up with cosecant squared on the other side, or eventually. Well, I'm going to turn everything into sines and cosines. So cotangent is cosine over sine. So I'm going to write this as cosine divided by sine. That's the numerator. And then the denominator is tangent, which I can write as sine divided by cosine plus 1. And now this part here, I'm dividing fractions, so that means I multiply by the reciprocal. So this becomes cosine over sine times cosine over sine, right? Multiply by the reciprocal. I'm drifting off sideways here, I don't know why. Plus 1. And now, these are just two fractions. I'm going to multiply them together. I'm going to get cosine squared over sine squared plus 1. And now what? Well, be alert of the plus ones, right? A lot of our trig Pythagorean identities, rather, all had plus 1s in them or equal to 1, right? Like sine squared plus cosine squared equals 1, those kind of things. So I think I'm going to leave that one there, but I think if I rewrite cosine over sine as cotangent again, then this is cotangent squared. So I'm going to write this. So this equals cotangent squared plus 1. And if you look at your Pythagorean identities, you'll notice that that is precisely cosecant squared. All right, let's look at one more example, and then we'll wrap it up with proofs. So I'm going to prove that 1 minus cosine divided by sine equals sine over 1 plus cosine. Now the reason I singled this one out is because it doesn't look like you have it's not like one side looks like simpler than the other, right? They almost look kind of like the same, except that's a minus, that's a plus, and the cosines are on the top. The cosine's on the top here and on the bottom here, right? So there's kind of like it doesn't look like one is simpler than the other. So I'm gonna let's see. I'm just gonna start with the left-hand side, and again, I gotta end with the right-hand side here. All right, so this is like one of the situations where it's not enough to sort of just substitute in identities. I actually might have to do something a little bit more proactive. And so what one thing I like to think about is I need this, right? This I'm claiming, or it's true apparently, that this is equal to this, and this has a 1 plus cosine at the bottom. So I don't have a 1 plus cosine at the bottom. I have a sine next to the bottom, but I can force there to be a 1 plus cosine at the bottom if I multiply the bottom by 1 plus cosine and the top. And then let's just see what happens. Like since I know this is true, then ahead of time, then I'm guaranteeing that this is just going to work out nice. So the top, I'm actually going to multiply the top out. I'm going to multiply the top out like the same way I'd multiply out any other binomial here. So that's 1 minus cosine and 1 plus cosine. 1 times 1 is, maybe I should make this a little bit cleaner. It's a minus cosine x. 1 times 1 is 1. 1 times negative cosine is negative cosine. Cosine times 1 is cosine, and it's negative cosine squared, right? Cosine times cosine. And when you add these all up, notice those cancel each other out. You get 1 minus cosine squared. It's a difference of squares. So the numerator is 1 minus cosine squared. The bottom is sine of x times 1 plus cosine of x. Now I'm not going to distribute. The reason I'm not distributing is because I want the only thing to be left at the bottom. What I want to be left at the bottom is this 1 plus cosine x. So I don't want to get it all tangled up with the sine of x. I want to leave it. I want to get the sine of x to go away. And it turns out that this is recognizable. Look for a few minutes or for a few seconds and see if you know an identity for that. If you found it, you should have found that that's equal to sine squared. So I can make that substitution. And we're precisely where we want to be, because sine squared over sine, one of them goes, and I'm left with this guy. Oops. Here we are. All right, so there's an example of one where you have to be a little more proactive, but nevertheless, the same principles are the same for all these proofs.